Right, now let us talk about refraction at the spherical surface. Okay, refraction. For refraction, the light definitely can pass through because it is not a mirror. It is just a piece of glass. The light can penetrate. So, same thing for this part also. We must first of all we must draw the incident and refracted ray, and then the second is just compare. Yeah, so we always start off with you must draw the incident and refracted ray. Always start with that. Now, for what is the equation that involved in this part? It is n1 over u plus n2 over v equal to n2 minus n1 over r. N1 is actually, for object, or we can say incident ray. Yeah, you can write that. N1 is the refractive index for first medium, okay, for the incident ray, and N2 is the refractive index for the refracted ray. Yeah, I can write like that. Yeah, this one N1 is N1 is the for the incident ray. N2 is for the refracted ray. Okay. So first of all, I draw the incident and refracted ray. For later on, I can compare to get the positive and negative. Okay, it is very important for me to draw the incident and refracted ray. Yeah. So okay, this is the object over here. Let's say the object is over here, and then this what surface is this? So what surface is this? Depend on the object. Object is over here, isn't it? Object is over here looking at the surface. This must be a we can say this is a convex surface. This is a convex surface, because it's like curved towards the object, isn't it? Curved towards the object, like this one, the object inside. Object is inside the glass, and this surface is what kind of surface? So depend on where is the object. Object is over here, so this one is a concave surface. This one is a concave surface because it is a curve away from object. You see, it curve away from object. It looks thin, curve away. Like this one. The object, this surface, what kind of surface? This is a concave surface because object is over here looking at the surface. Yeah, he's looking at the surface and he sees that it is a concave surface. Just like the object over here looking at this surface. So this object looking at this surface, this one looks concave. This one also object looking at this surface, this one also seem concave. Concave surface. Understand or not? And then how about this one? This surface for this object is convex because object is over here. Object is over here, and this he looking at this surface. Looking at this surface, so this surface seems fat to this object. It curves towards the object. So this one is a convex surface. This is a convex surface. Understand? And this is a convex surface for this object. This one is a concave for this object. This surface also concave towards the object, but this surface is convex towards this object. Because this one, the object is looking from here, so this surface seems fat towards the object. It's a convex surface. Convex means fat. Concave means thin. Okay. Now, okay. Just now I'm talking about the refractive index. This N1, N2, N2 minus N1. So N1 is first of all you must draw the incident ray and refracted ray. Okay, as I said before. This is the incident ray and this is the and the following is the refracted ray. Following is the refracted ray. Where's the refracted ray? This is the reflected ray. Understand? Reflected ray and refracted ray. Okay, so now N1 is the refractive index for incident ray. Yeah, so is the refractive index, means here is N1. Understand or not? Outside, like this one, outside is air, isn't it? Outside is air. So this is the refractive index N1, and then the light enters into the second medium, isn't it? Enters into the second medium. So this second medium is N2. N2 already. Refractive index for the refracted ray. N1 is the refractive index for incident ray. N2 is the refractive index for the N1 is the refractive index for incident ray. N2 is the refractive index of the medium for refracted ray. Okay? Like for the second example, like this one. So which one is N1? N1 is the glass. N1 is the glass because it is the the incident ray. Refractive index for incident ray. Refractive index for incident ray is N1. Refractive index for refracted ray is N2. Understand or not? So you need to see. Okay. Now, the next, U is the object distance, V is the image distance, and R is the R is the radius of curvature for the surface. Again, for this one, the object distance compare with incident ray, because it is always what? It is the object emit the light, emit the incident light, and then it is the refracted ray form. Refracted ray form the image. Understand or not? So if object same side as incident ray, positive, it's a real object. If object opposite from incident ray, it is opposite, means it is a virtual object. U is negative. And then similarly, if the image is same side as the refracted ray, it is positive and it is a real image. If image distance is opposite from refracted ray, then it is negative and it is a virtual image. Understand? Okay. Now, how about the R? R also the same. R also compare with refracted ray. Remember, only the object distance compare with incident ray. All the rest, only the object compare with incident ray. All the rest, image, radius, all compare with refracted ray. Only the object compare with incident ray. The rest, like image distance, radius, curvature, all compare with refracted ray. Okay? So same thing. If radius of curvature same side with refracted ray, then it is a positive R, or real radius of curvature. If the radius of curvature opposite side from the refracted ray, then it is a negative R, or virtual radius. Okay. Now let us look one by one. So for first example, so let's say the image is formed at this side, So look at where's the R. Look at where's the R. I just want to rub off this one first. Rub off this one. Okay. Now look at where's the. Okay. First, look at this. The first diagram. Where is the object? Where's the object? Object is over here. So where is the? Okay, I already draw the incident ray and refracted ray. Incident ray from the object and then go into. Yeah, the light can pass through. Not like the mirror. The mirror, the light cannot pass through. Yeah, just reflected away. But this is called reflection. Yeah, this is what we call reflection. But for the refraction, the light can pass through. Can enter into another side. Okay. So object is over here. So this is the incident ray and refracted ray. So where is the object distance? Object distance is, where is the object distance? Object distance is over here. Object. So this object is same side and incident ray. So this is positive, positive object distance. Now, how about, let's say the image. Let's say the image is formed over here. Over here. So where's the image distance? Image distance is over this side, isn't it? This is the V. So this V, it is same side as the refracted ray. V compared with refracted ray, same side. So it is positive because same side. Yeah. That means this is a real image. That means if I put a screen, let's say if I put a screen over here, the light can fall onto the screen and form a real image. Understand or not? Okay. So if the image is formed over here, where is the image distance? The image distance is over here. This is the image distance. If V is over here, this V compared with refracted ray, V compared with refracted ray, opposite. So that's why it's negative. It's negative. So negative. That means if I put a screen over here. If I put a screen over here, do you think anything will form onto the screen? No, this is not. This is a refraction. The light already go to the other side. It's not reflected away like the mirror. The light for the mirror reflection, the light is reflected back. Yeah. But for the refraction, the light already go to the other side. Here has no light. What I can say, here has no light at all. No light already. The light already go to the other side. Here, over at this side, here got light. Here got light. Here got light. So here it form a real image on the screen. But here, the screen, the light already go to the other side. Here has no light. So if your calculated image is formed over here, this is not a real image because no light is fall onto the screen. This is just a virtual image. This is just a virtual image. It's a virtual image because no light fall on the screen. Okay, V is negative. Okay, opposite side from the refracted ray, no light. Understand or not? And then how about the radius of curvature? The radius of curvature. Look at the sphere. How is the sphere looks like? This is the convex surface. So you see this sphere is over here. You see not? The sphere is over to the right hand side. The sphere is to the right hand side. So the center curvature is over here. Center curvature is over here. Center curvature. So the radius is over here. This is the radius. Do you see that? This is the radius. So radius for this convex surface, this radius compare with refracted ray. Radius compare with refracted ray. So radius and the refracted ray same side. So same side is positive. Positive. Understand or not? This R is positive. The same side. Very easy. Okay. Same side is positive. So very easy. Only the U compare with incident ray. B and R compare with refracted ray. Same side positive, opposite side negative. That's it. No need to remember all the terms. All the convex surface must be positive, concave surface must be negative, positive R and negative R. Very hard to remember. Yeah, I like this way much more because I just remember to draw the incident ray and refracted ray, then look at where's the position, the size, the shape of it, the picture itself. The picture itself already tells me which one is positive, which one is negative. Because I just compare with incident ray and refracted ray. I determine the positive and negative side from the picture, not from memorization. Understand or not? Okay, so look at this one. If the object is inside the glass, also I draw the incident ray and refracted ray also. Incident ray and refracted ray, remember this is N1 and this is N2. Okay, N1 is for incident ray, N2 is for the refracted ray. Okay, so now what is the object distance? Object distance for this one, the object distance must be object distance is over here, isn't it? So this u must be same side with incident ray. Okay, the u is same side with incident ray, so this is positive, the same side. Now for the rest, like the image, if the image is formed at this side, so the image distance is over here. So this v is same side as the refracted ray. V compared with refracted ray, same side. So is v is positive. This is a real image. And how about for if the image is formed over here? Let's say the image is formed over here. So where is the image distance? This is the image distance. This v is over here. V is opposite to refracted ray. V compared with refracted ray. V opposite to refracted ray. So this v is negative. This is a virtual image. Understand? This v is negative. Virtual image. Very simple, huh? Opposite negative, same side positive. Now how about the r? You see, this r is the sphere is over here. You see the sphere, same like above. So but this r is over where? Which position? This is the r. You see that the r is over here. This is the r. You see that? Because the center curvature is over here also. Center curvature, because the shape is like this. So this is the r. Is same side with refracted ray or opposite? Become opposite already. So this r is negative. This r is negative. You see or not? I should put a black color. This r is negative. Why r negative? Because it is the radius is opposite to refracted ray. R compared with refracted ray. So r is negative. Okay, because opposite to refracted ray. But for this one just now, this r is positive. This r is positive. Because this radius is same side as refracted ray. But for this one, the r is opposite to refracted ray, so it's negative. So that's how it, yeah. If some reference book, it will say convex surface must be r positive, concave surface must be r negative. You remember that by memorization. Very hard, yeah? For me, I don't like. I like to draw diagram and I just compare to get the positive and negative. Now for the next one. This one, object is over here. This is a concave surface. Okay, I also draw the incident ray and refracted ray. Yeah, this is the incident ray, and this is the next one. This is the refracted ray. Sorry, I don't like the color so dark. And this is the refracted ray. Okay. So the same as the following one. The object is inside the glass, so this is incident ray, and this sorry, again, this is the refracted ray. See that? That's the difference. Yeah. Now let's look at the first one. This is a concave surface for the object. So this object is this is the object distance. Okay, u same side. U compare with incident ray. Again, u compare with incident ray. Same side is positive. U is positive. Now the image. Let's say the image is formed over here. So the image is formed over here. This v is over here. So this is same side with refracted ray. That means got light. So this is v positive. Understand not? V is positive. This is a real image. And then what about if the image is formed over here? Real image is always inverted. Virtual image is always upright. Okay. And then what about this one? Again, so if the image is formed over here, so the v is over here, yeah. Image is formed over here, v is over here. So v is opposite to refracted ray. So this is v is negative. So this is a virtual image. Understand? It's the virtual image. How about the r? R. Look at this sphere. The sphere is over here. See not? This is a sphere. This sphere. So center curvature is this is the center curvature. Okay. center curvature. So where is the R? R is over this side. R is over here. You see that? This is the R. This is the R. R over here. R is over. This R is opposite to refracted ray. You see that? R is opposite to refracted ray. So this R is negative. Okay. This R is negative because opposite to refracted ray. R is opposite to refracted ray. Understand? This R is an opposite to refracted ray, so it's negative. And then how about the last example? Opposite R opposite to refracted ray, so it's negative. Now how about this one? Object inside here, okay, refracted ray outside. Now so object distance is over here. This is the object distance U. This U same side with incident ray, so this U is positive. Now how about the image? Let's say image is formed over here. So where's the image? Image distance. Image distance is here. V is over here. So it's a same side with refracted ray. This V is a positive. So this is a real image. Then and then how about this one? V is over here. Image is, let's say image is formed over here. So the V is over here. Yeah, the V is over here. So this V is opposite to refracted ray. This V is negative. So this is a virtual image. Yeah. Yeah. So this is a virtual image. Understand? Because V is opposite to refracted ray. Now how about the R? R. Look at the R. So this is the convex surface. So this is the sphere. You see. This is the so this is the sphere here. So the R is the center curvature is over here. So the R is over here. The R. So this R is same side as the refracted ray. So this R is positive. R is positive. And that's how we determine same side positive, opposite side negative. Very simple. Just draw the incident ray and refracted ray for us to compare all the U, V, and R. Understand or not? So that's why some reference book, some lecture note says convex surface. You see, convex surface, all the R must be positive. You see, convex surface R positive, convex surface R positive. But for concave surface R is negative. Concave surface R is negative. You see that? Convex surface R positive, convex surface R positive. Concave surface R negative, concave surface R negative. This is people memorize. People memorize convex surface must be R positive, concave surface must be R negative. You memorize like that. But if I ask you to explain why convex surface must be R positive and why concave surface must be R negative, you cannot explain because you don't know the concept. So my method here is actually I back to concept. I back to the incident ray and refracted ray that form the image. I back to the concept. The concept is positive is where the light is. You have light, is positive. You have no light, is negative. Like this convex surface, the R, the radius, is at the place of reflect. This radius is at the place with light. Got light. That's why this R is positive. But this concave surface, the R is at the place with no light because refracted ray already go to the other side. At this side, the radius is the refracted ray at the left hand side. The radius is at the right hand side. So this radius at the place with no light. No light. That's why R negative. Okay. This convex surface, this radius is at the place with light. Got light. Got refracted ray. Got light. So this R is positive. That's I back to basic. I back to the concept to determine the positive negative. So for me, it's easy for me to use this equation. Easy. Yeah. So that's how for refraction and spherical surface. Now, next one we will talk about lenses. Also use the same method. I told you already, my method can use for all subtopics for the entire chapter. Okay. See you in the next. Bye.